Sierra Clement is our next student speaker, using carbon dating to retrace humankind.
Hi, thank you all for coming today. My name is Sierra Clement, and I'll be talking on using carbon dating to help us retrace humankind and kind of our history. So to start with, I want to go through what is carbon dating, what does that mean, where does that come from, and then how it's being used, what it's being used for in order to kind of backtrack and figure out where we came from as a human civilization. And lastly, is it foolproof? Is it something that we should be relying on to give us an accurate representation of where we came from as a human civilization? So to start with, what is carbon? Carbon is the sixth most abundant element found in the universe. It consists of 3 different known isotopes. And so there's carbon-12, carbon-13, and carbon-14. The one that we're going to be looking at today more closely is carbon-14. Carbon-14 consists of 6 protons and 6 neutrons. Oh, sorry, that's carbon-12. Carbon-14 consists of 6 protons and 8 neutrons. What that means is that it makes the atomic structure of that unstable, so it wants to change. And when it goes through that change, it's what we call radioactive decay. And radioactive decay comes in 3 different forms. There's alpha, beta, and gamma. And carbon-14 goes through beta decay. So it switches one of its neutrons into a proton and emits an electron, as you can see in the picture to the right. And when it does this, it actually changes the atomic structure of the element itself. So it changes from carbon to nitrogen-14. The reason this is so interesting and the reason that this applies to carbon dating is this decay process is how scientists use it to track and go back in history through the means of a half-life. So what a half-life is the way scientists measured the decay rate. Half-life is the amount of time it takes for half of the amount of that element to decay. And what's so cool about it is that the half-life doesn't change, it's constant. So for instance, if you look at the graph up here, you start with 100% of whatever element you have. And then over a certain amount of time, half of it decays, and it turns into 50%. And then 25%, 12.5%. And the rate at which this happens is the same. For carbon, it's 5,730 years. And so that same amount of time will go by for half of it to decay, half and half and half. How this plays into radiometric dating is scientists have come up with an equation, such as this, that they use 4 different variables to track the amount of time that it takes for a certain amount to decay. So for instance, if you're given the initial amount of carbon, then you multiply that times the half-life, or times 1/2, which is significant of the half-life, raised to the time over the known half-life. And that gives you the amount of carbon that should be left after that certain amount of time. So with this equation, scientists are able to determine the amount of time that happened between a certain amount of carbon to the amount of carbon that was initially there. So how is this being used today? Today, scientists are still using this in the field of archaeology. And in the 1940s, when it first was discovered, it really revolutionized the field of archaeology. Because before that, scientists only used known things from civilization, so recorded records or hieroglyphs, things like that, to be able to trace humankind, or tree rings, which are super credible. But this carbon dating was so revolutionary because you could take any piece of organic material, so any material that had carbon in it, human remains, plant remains, or animal remains, and you could test it and actually get a date for how old it had been since the time you tested it. As I was looking into this, I was thinking, okay, what kind of cool, significant things have we as a people tested? And what I found was this, the Shroud of Turin. And maybe some of you know what this is. I didn't before I started researching it, but it's actually a piece of cloth that bears the image of a man that had once been tortured and crucified, which lead many to believe that it was Christ the Messiah. And so the thing is that the religious community was super interested in what this cloth was, and the science community was super interested in what this cloth was, because scientists couldn't figure out how an image like that could come and be impressed onto a piece of cloth. And for that reason, when carbon dating came out in the 1940s, people were desperate and wanted to find out how old this cloth was to see if it really could be Christ the Messiah. They did the testing in January of 1988. They took a piece of small cloth to 3 different labs, and they all tested them at the same time. And the results came back. And as you can see, the results are in the first column of that table, and they all came back with about 690 years, putting the cloth at about 1300s. Obviously, this couldn't be Christ the Messiah if he had died in the early turn of the century. However, what these results came back with wasn't answers, but rather more questions, because now the religious community was super skeptical of carbon dating. And they started to question the reliability of the test. And so from here, they didn't necessarily question the math behind it or the science of the actual process, but they were questioning the assumptions that it was founded on. So these assumptions mainly center around what we say is the initial amount of carbon. Like I said before, in that equation there are 4 variables. There's time, that's a variable, the half-life, which is a variable, the initial amount of carbon, and the final amount of carbon. Now, the time is the thing we're solving for, and so we only need to know the other 3 things. The half-life is constant, like I said before. We know that for all radioactive elements. And the final amount of carbon is something that we can extract from the sample and get to know, and it's foolproof. The thing that scientists assume is the initial amount of carbon. Where they get this assumption from is that all carbon-14 and carbon-12 comes from our atmosphere, and we breathe that in, or plants breathe it in through photosynthesis, and we're intaking it constantly as we're alive. However, when we die, we stop intaking it because we stop breathing. And so what Willard Libby found when he first revolutionized this in 1940 was that amount of carbon that's in the atmosphere must be the same amount of carbon that's in each of us. However, what skeptics claim is that if the amount of carbon in the atmosphere isn't the same amount that's in us, then the premise that that is the initial amount of carbon could be wrong and could skew the results of the carbon testing. In conclusion, carbon dating is a radiometric dating method that uses the isotope carbon-14 to help retrace things back in time. Its uses are really important in the field of archaeology because it allows scientists to actually get a date on things. However, science skeptics do have credible credible skepticism as far as the assumptions go. And that's what I concluded after all my research, that even though I do believe in the math and the science behind carbon dating, and I think it is obviously very good, there are some assumptions that are made that people do have a means to question. Whether or not they're valid would require further research, but I think that they do have a means to be skeptical of it. And that's my presentation. Any questions about carbon dating? No? Okay, cool, thanks.